Good morning, everybody. My name's Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation, and we're moving into the area of IoT agents today. More importantly, this is very far down in the stack, so we're going to be specifically talking about IoT agent gateways. So let's find out what we're going to be doing today. I'll be going through the various existing IoT agents. Obviously, the whole point of FIWARE is that it should be agnostic to whichever protocol or payload or whatever that you're actually using. So I'll review the existing IoT agent transport binding architectures which are being used in the FIWARE catalog. There are a series of free-to-use open source software which covers a wide range of potential use cases from HTTP through to OPC-UA. There's been a recent development in the robotics area on ROS2, for example. Now, on top of this, I'll be creating and discussing a novel IoT agent, discussing how you need to do this, what things you could be dealing with. And in this particular case, I will be using the IOTA Tangle. This is an acyclic graph, basically a blockchain, but a blockchain without a lot of the heavyweight additional bits on it. And it has some reasonable use cases. There are some things which you definitely shouldn't be doing with the IOTA Tangle, and I'll also discuss those as well. But whenever you decide which devices you want to use, which protocols you want to use, you need to make the architectural choice in an informed manner. And this is where we will just discuss this as how this goes forward. In particular, this particular session will involve quite a few slides looking at code, explaining how the various parts of the gateway architecture actually work. Obviously, the idea is that you can use the IOTA Tangle directly if you use this code, but if you have some novel use case, then these will be the standard steps which we will need to deal with. So sensor measurements, which is data coming from the device onto in this case, the transport IOTA, and then into the context broker, or rather into the IoT agent and then into the context broker. Actuation commands going southbound, which are the reverse. You do something in your digital twin, and then you get something to happen in the real world. And of course, when you actuate, you get an acknowledgement back saying, hey, something has happened. But also in this particular architecture, because we're talking about a gateway architecture, there are gateway bindings. It's a kind of intermediate thing in the middle. So, and then once you've digested all this, there'll be an overview as to when you would want to use a gateway solution and when you'd want to consider other ways of customizing the code. Obviously, all of the basic library is free open source software. You can have multiple different ways of getting into this data. You can write your own stuff using your completely own stack if you wish, and it's going to explain what a good choice is so that you can reduce maintenance, you can keep the bugs down, and make sure that actually what you end up with is a usable solution. So first things first, let's have a look at some existing IoT agent bindings. The obvious place to start, and this is where I usually run the tutorials, is using HTTP. We're all familiar with what HTTP is. You use it on the internet all the time. It's very easy to set up my little test application. It's it's a handshake, basically. You just have a direct connection. It's basically it's a web server listening, WebSocket service listening on the device. They are waiting for something to come in, or they will push an HTTP request directly up to the IoT agent, which again would always be listening on the relevant port, relevant location. It has many advantages. It's very easy to write code. If you go to, say, a Raspberry Pi, there will be an HTTP library. Very easy to write a little 4 or 5 lines of code to say, when I've done something, push this HTTP request up to some URL which I can somehow configure into my system. And of course, it's very easy to mock as well. This is why the tutorials tend to use HTTP. However, the disadvantage of HTTP is because it's a request response, it has a higher power requirement than some other architectures. Now, at the moment, HTTP is used in the context brokers, but this is not actually a requirement according to the NGSI specification. Other protocols could be used or could be developed for a compliant NGSI LD context broker. But given that you have an HTTP context broker already, you're going to have HTTP in your system. You can do things like have a load balancer in front of your system. You can potentially add in some sort of proxy, like a pet proxy, to say give you some sort of security around incoming data, but there isn't that much you can actually do for customizing this and using a novel transport. So HTTP, very easy to use, but not very customizable. Moving on to the second possibility is MQTT, get that right. And in this case, there is not a direct connection. It's more like posting a letter. You know, you hand a letter into the postman. Eventually, they'll wake up and say, "Any post for me?" And then they'll pass it on. What this means is that devices choose when to receive their communication. They don't have to be always on. This means that they are lower power required. Obviously, it means there is latency in the system. You can't have an immediate response. This will be absolutely useless if you're trying to do a real-time system. But publish subscribe is asynchronous. Now, this means that there's a much higher degree of ability to customize the architecture, and indeed, this is the basis we will use for the gateway solution, which I'm talking beforehand. The point being is that if it's asynchronous, you can say, IoT agent, talk to someone. Someone can decide what to do, and then you can do your custom stuff further down, and it will respond when it's ready and it's got the right responses through. So it's a much better option for doing the customization. Now, there are multiple IoT agents out there. This is the architecture which you would get for the Sigfox IoT agent. And this is actually an example of what I would call a gateway solution. The callbacks into the Sigfox network server are indeed HTTP. However, the IoT agent is communicating indirectly, because what happens is you have your little device somewhere in the field, somewhere low power. They will talk to a base station, Sigfox gateway, which will then talk to a cloud server. And indeed, the cloud server will do all the clever stuff of working out how the communications work, failures, stuff like that. And then we'll pass the information back up to the IoT agent. It's very much, if you look at the code inside the Sigfox IoT agent, it's very much focused on saying these are the bits within the payload. This is what they mean. You can customize that using your internal attributes. And I pick the top 5 bytes is going to be, I don't know, the temperature. The second bit is going to be the humidity, and so on and so forth. And that is then pushed out to the IoT agent. Again, because the IoT agent to network server is HTTP, there is not really that much opportunity to use this as a basis of further customization, but it's a good example of how you can talk to a system indirectly. You'll see that the LoRaWAN IoT agent has got a very, very similar sort of basic architecture. The IoT agent again talks indirectly, and it's got a lower power requirement. Once again, it goes to network server, this time over MQTT, and then to the concentrator gateway, and then out to the devices, or indeed the other way around. If you're talking about, I think it's class. It's only Class A and Class C devices which do actuations, which is what I was talking about. But for devices, for sensors, it goes from device to concentrator to network server, and then up to the IoT agent. Very similar architecture. Again, it's a star of stars, and it's usable for low power devices. As you can see, you've got no real flexibility in what the device will do. It's just out there in the real world. We cover a wide range of different protocols, and indeed within the robotics domain, you are talking about OPC-UA. If you're not talking about ROS2, which is the new thing which is coming through. But for here, you have the devices are actually programmable logic controllers, and they are communicating with an OPC server, and you're using the OPC-TCP binary protocol. Again, you're talking about an intermediate between the IoT agent and the device, in this case, the logic controller. Once again, we are talking here. There is a gateway solution. Obviously, above this IoT agent, you would have the context broker, any other devices in the higher layer. So that was an introduction to the various architectures which currently exist. But what is the IOTA Tangle, and how and why would we want to use it with FIWARE? Well, IOTA is a distributed ledger. It's not a blockchain. It is, however, an acyclic graph. What this means is that elements further up the chain are pointing in one direction towards multiple elements further down the chain. So if I know that something's correct, I can say the following are also correct, and then I'm having a trust situation here. So it covers the same use cases as a traditional blockchain without the heavy weight of requiring an entire block, basically. It's designed for scalability and performance, but you should realize that performance of a blockchain will never be as quick as a protocol which is designed to just pass messages. The whole point about distributed ledgers is that you have a record of what has been occurring. Therefore, there needs to be some, in this case, proof of work to decide, okay, this really is what we want, this really is what we're doing. However, because the tangle itself is connected across multiple nodes, and the name gives it away, there is a reduced time and reduced energy need to resolve transactions. And perhaps the most important point here is that there's no miners, so it's feeless. So you can use this as well, but you will use it for indelibly, and this is the important bit, indelibly recording transactions across a global network with a resolution of approximately a minute. Now, if you are merely dealing with dealing with fast-flowing data, this is not what you want to use. It's for stuff where you've actually got some reason for the proof. All of the claims of any blockchain come at a cost. You can see here, this is a slide taken from the IOTA Foundation website. It is indeed highly scalable and low resource requirements, but it says finality within seconds, not milliseconds. You know, you don't want to say, oh, I really want to have everything stuck on my distributed ledger forever and expect a really, really quick response. Obviously, if you're talking about robotics, you're talking about microseconds. So you need to consider, do you really need a blockchain for connecting your IoT devices? A good example of when you might want to do this is, let's say you have a financial transaction, or you have something where the user will eventually pay. In that case, the fact that something has happened and really has happened and is agreed to have happened by both the device and us as the control of the context broker, it's an excellent opportunity to say, okay, we really received this data and it really happened in this particular fashion. Now, for the demo later on, I'm just going to be using the little tutorial app, ringing my bell and sending a stream of data. That really isn't the right use case for this, because obviously every single time you're doing something, it's going to have the overhead of the resources. What you really want to do in that case is you would end up with a hybrid. You could very easily have your common functions. Let's say, for example, you're tracking the location of a robot. Your common functions would be following the standard MQTT, let's say IoT Agent for JSON protocol, just sending a stream of data on a regular basis. But if they want to do something really important, like, I don't know, receive a payment, or say open a locked box or something, then that's when you say, okay, they really did put in the secure key code. That's the ones you want to have using this particular pattern. So you should consider that when you are building up a digital twin, you could have multiple devices or configured devices which could build up the overall viewpoint of, in this case, the robot. So you could have the GPS device could be using a different protocol to the unlock the box device, because it makes more sense that way. Obviously, yeah, you can link the data using a provided by metadata relationship to be able to get all the information into the system. So you don't want to say all of the data is IOTA, or all of the data is OPC-UA or whatever. It's a matter of saying, okay, these are the ones which use OPC-UA, these are the ones which use IOTA, these are the ones which use some third protocol. Indeed, if you look at citywide installations of FIWARE, you will probably find there are a tranche of different IoT agents all running for the on the same cloud server, some of which are retrieving information from, say, ultralight devices, some are doing it from JSON, and so on and so forth. So how are we going to put a FIWARE into the IOTA Tangle? Well, as you can see, this is a gateway solution. We have an IoT agent, which is talking, in this case, MQTT, and it talks MQTT to this gateway, which is then going down into the IOTA Tangle and pushing stuff to devices. we're reusing the MQTT binding because that way we can keep the communication asynchronous, and we're able to modify the protocol from MQTT to something else by this gateway element, as indeed this is the way the Sigfox or the LoRaWAN work. It also minimizes the amount of code changes which need to be made. Indeed, there is an example which is available in the FIWARE tutorials where you can run this for yourself. Okay, so first things first, let's start from the bottom. We're going to go from our device and we're going to connect into the IOTA Tangle. All you need to do here is to connect to a live IOTA node. Obviously, you can use the demo system, but once you're talking about a properly scaling version, you need to get a more robust system. Obviously, the tutorial is using dummy or free to use elements, and you just need to push data in a well-known format, well-known by the gateway, to a common message index. Now, what happens here is that once the data has been recognized as being valid, there is an event raised, which means I can use this, in this case, FIWARE-IOTA's message index to listen for changes on that and use that in my gateway code. It's quite simple. I mean, this is just a little piece of JavaScript, Node.js code. You will notice that looking on the right, all you're doing is you define the shape of your payload. This particular one is an ultralight payload. You can see it's following the paradigm which is used within the get HTTP format. So it's got this I for the device, K for the API key, and the D for the state. And then on top of that, we also need to ensure that as well as any other data we've got in there, we must include a timestamp, because sending data to the Tangle could take a minute. And if you want to be able to work out what happened when, you're going to have to include the time coming in from the device. This is actually good practice for any asynchronous systems talking to FIWARE, so that you've got a proper observed at, which can be retrieved, or time instance in the case of NGSI v2. And then you'll notice on the left, I'm not actually doing the push to tangle. What I'm doing is I'm putting it into a queue so that it can be dealt with. You can see here that actually connecting the tangle is quite easy. You just pick a node. This has got the Chris's nodes IOTA Cafe, and then it creates the client. The client, you submit the data, but it will take time to respond, and it may not work. If it doesn't work, it could be that the node is not responding. It could be that it's down for whatever reason. You just need to send it again to make sure you have an acknowledged response before you continue. The queue in this particular case is throttled. It's throttled to a maximum of 8 entries. Now, this is because obviously adding messages to a queue which is failing is going to take additional memory resources. May not be a big issue if you consider that each individual device has got its own memory, its own ability to do things, but at some point you want to stop flooding the tangle with data which is not being sent properly. You need to have some sort of retry and failure. This is actually a common paradigm which you'll see throughout the code we've got here. Now, going the other direction, a device which is an actuator will need to, again, connect to the IOTA Tangle. It will need to listen on a common message index. You've noticed this time we're using FIWARE command rather than FIWARE-IOTA, so that we're informed, hey, something's happened, so let's go off and do something. And indeed, all that the device needs to do is listen and then retrieve the data and unpack it. Very similar looking code to the previous example. Again, we are connecting to this node for a specific client, and we're listening to a topic. When we retrieve the data, it might be an error. So again, you'd need to have some error handling, or indeed, if when we're trying to do the initial connection, there may be an error. So you might need to have a multiple connect. And you can see here, assuming we've got some data, what I'm doing here is I'm waiting until the next available time slot to be able to read the data and configure it. Now, the point here is that once again, there are multiple things going on. All that the Tangle is doing is it's informing me, hey, I've got some data. It's not giving me the data itself. I need to be able to read the data as in this case, it's a buffer. It's going to be a UTF-8 string based on my message ID, and the message ID itself will make sure that I can actually get the appropriate data for the information that's come in. At that point, I would need to process the command. So processing a command takes a little bit longer. Processing command continues, of course, once you are responding. So once again, I will need to push something again northbound to be able to explain what's going on. It's very, very, very similar to a measure. In this particular case, when we are processing the command, we need to make sure that however we've defined the data in the Tangle, this is split using ands and equals, as you'd normally expect for an HTTP string, for example. We need to make sure that we can get hold of, in this case, the appropriate API key, the appropriate device ID, which is what's been configured in the IoT Agent, and you do your error checking at this point. At this point, you would then actuate the device to work out, what am I doing? It might work, it might not, so you need to send an appropriate acknowledgement back up into the Tangle itself. You can see that the response is very much like the response you would get for a device response. But there's more. This is so far just going into the device, into the Tangle, but obviously we need to get the Tangle somehow into the IoT agent. And this is done by repurposing the MQTT gateway, MQTT binding. The IOTA Tangle itself, we need to listen on to this ATTRs and be informed that something is settled. Once something is settled, we can then create an appropriate key. You can see that the MQTT key here is UL/API key /devices ATTRs. This means that we are deliberately placing in the measures the payload format. This in turn means that you could have multiple IoT agents listening in onto the same MQTT broker and just receiving messages appropriate to them, because it says I can interpret ultralight, therefore I will deal with this. I can interpret JSON, I will deal with this. The code is beginning to look a little bit more repetitive now, because we've already seen this with devices, in that once again we need to subscribe to a relevant message key, and then receive the message, and then finally on the right hand side we would forward as MQTT. All that is that once again we have an MQTT client as well as the IOTA client doing the change of protocol. You can see that we have unpacked the data in the same way as beforehand using the unmarshal function. So we've got the various parts, which once again we want to process on the next available time slot. So there's quite a lot of asynchronicity which needs to be placed into the system. For commands, we once again the gateway needs to be a proxy for pushing stuff back onto the Tangle, but it needs to be listen for notifications from the broker and then pushing forward as necessary. Very similar to the elements beforehand, in that we're listening to all this plus command elements, and then we are extracting the data and pushing that to the IOTA Tangle in the appropriate format. There is, of course, the need to acknowledge the responses. So this is once again this intermediate step. This time listening on command exe rather than on command. Now, important for the error handling, which would be on the previous slide, is that if for whatever reason we're unable to process a command going southbound, we should short circuit the system and send an error response straight away. So let's say for whatever reason, you've unplugged your internet cable or whatever, and I can't send anything to the Tangle, it can error quickly. This once again is very, very similar. It's just doing the same thing as the previous element. This time it's doing on the acknowledgement. So let's see if we can get this thing to work in action. This is the overall architecture of a working IOTA system. This one is going to be running on MQTT for its, I think it's ultralight, ultralight protocol. So we're just waiting for Orion to come up, and we're provisioning some devices. At this point, we can just go into the Postman collection and have a quick look to see what we've actually got. So let's see how many devices we've got. Connecting to devices. Where is it? Device CRUD actions. See if we can you see we've got some devices. We've got motion sensor. Now you notice that the devices I have already provisioned, I've provisioned them as using the MQTT transport, and this is because it is MQTT that the IoT agent believes is connecting to the device, because obviously it sends out MQTT. And of course, it doesn't understand that the IOTA Tangle is down there at the bottom of the system. But you can see all these usual devices are being sent in as you would expect. bring in the dummy devices. Now I can make a motion detection element. You can see it sensed something. It will take some time to respond within the IOTA Tangle itself, because obviously it will need to see whether this is actually connecting. It could be the case, and I'll just bring up the logs. Sometimes this system takes a few attempts to get started. Yeah, here we go. So this is the log, and you can see here that what's happened within the IOTA gateway is that it sent a C equals 1 and C equals 0, so that and it sent the timestamp, at which point it sends something further up the system in the format of a MQTT signal. You can see indeed the tangle has got a key, and indeed if you went over to the IOTA Tangle website, this particular information is now indelibly placed onto that blockchain. You can do the same thing with a message being sent southbound, and you can see that what happened there was that eventually the bell rung. It ran very, very quickly that time. And what happened in this case is that once again, we received a command from the IoT agent. It was translated to this particular command on the Tangle, and it had a valid message ID. And this is the message. This is where the data is held in the Tangle to give the information. This was the response which was received from the device. How do you provision your devices? Well, I think I showed you briefly is that this is an MQTT device as far as the IOTA gate, as far as the IoT agent is concerned, because it's talking MQTT to this gateway element. Therefore, you just don't need to have a resource element when you're provisioning the service, and you don't, and you can just put the transporters MQTT. You can see this one was ultralight, and it had the ring command. Similar with the motion sensor, it knew it was a count, so that within the context broker, it will come out as count. This is all standard IoT agent stuff. Within the devices, nothing particularly unusual here. We are following the standard NGSI access calls. I could get the device by just going context broker and the URN of the context broker. I can actuate using a patch and to put a certain amount of information. So in this particular case, it was a ring command of 3 seconds. Conclusions. When to use the gateway pattern? Well, the important thing here is that I need to have an existing asynchronous transport to leverage. In the case where I'm just doing HTTP, I can't deal with that. And can I leverage an existing payload? I have not modified the payload from ultralight. This is an ultralight format. Obviously, you would have the opportunity to say, I don't know, change a bar to an equal sign or what have you within your gateway itself. But ideally, it should reach the IoT agent in a format the IoT agents already can deal with. Obviously, they have the Jexel parsing, which is able to do more stuff. And thirdly, as I mentioned beforehand, is using a gateway going to be efficient? I just did a simple command. I just did one valuable transaction. This is going to be worthwhile. I could answer all three for this particular case, and therefore using IOTA Tangle in this case makes a lot of sense. There are, of course, other alternatives. You don't use the gateway pattern for everything. Of course, you can't see it in there all the time. If, for example, you have an existing payload, but you just want to do a new transport. Let's say you wanted to add in web sockets to the IoT agent for JSON. Makes no sense to use a gateway pattern for that if you could actually push it directly back into the existing code base. This is free open source software. So if there was an opportunity to have a relatively lightweight transport being added in to an existing IoT agent, put it back in there, everyone can use it. It also means everyone can maintain it. You'll continue to get bug fixes. You'll continue to get updates to the NGSI interface because it's a common or commons source of information. If, however, you have a new transport which has got heavyweight dependencies, and this is the case for the IoT agent for ROS2, where you may want to bundle in additional definitions of messages, for example, it's not going to be accepted as a PR directly because not everyone wants to have a massive bloatware IoT agent. Then you need to shadow. You can, again, you can fork the existing IoT agent, periodically pull up their upstream fixes, but keep your stuff separate. If you have a new payload, as indeed the ISO XML, ISO bus IoT agent has, you don't have to start from scratch. You can actually just take the closest IoT agent. I believe this one was IoT agent for JSON, and then just rewrite the code as necessary. There's another webinar on writing custom IoT agents. If, however, you want to do, say, both a new payload and a format, you're going to have to, again, start from the code base and rewrite it as necessary. You don't have to use the existing IoT agent node lib. Of course, that gives you all the provisioning information and pushing data up to the context broker for free. But if it's a fairly simple agent, we're just doing pushing simple data, you can use whichever data format you wish. In summary, low-level IoT transports and payloads are irrelevant to context brokers. Throughout this webinar, we've not dealt with anything more than just sending a patch report. That's the whole point. The NGSI interface does not care about the underlying details. It may be the case that you want to add in a certain amount of metadata so to help reuse your system. You might want to, in the case of the ROS2 IoT agent, you might want to use metadata rather than internal attributes to say which topics you're pushing to, for example, for debugging purposes, let's say. But in most cases, you just don't care what's happening. You just do a patch. It works. It does something. And every IoT agent is merely a parser and a transport binding. You look at the code. There's about 7 files in each of them, and that's it. It is just a translation layer. But you could, of course, have additional parts of the network further down your system. So there could be repeaters, there could be other parsers, there could be other elements further down. So as mentioned beforehand, you can create your own new IoT agents, or where necessary, and hopefully this is explained when a gateway might be useful, you can create a custom gateway to hive off some processing. In this case, we were dealing with probably a multiple protocol system, some of which data needs to be held indelibly. In that particular case, the IOTA Tangle is a good candidate for a single source of truth. This is where they are positioning themselves within the DLT domain as being the ideal system to use for DLT and IoT devices. That's where the name comes from. But don't blindly convert. Make sure that you use the appropriate data, the appropriate protocols to push your data as necessary. Particularly when dealing with DLTs, it should always be remembered that settlement does take time and error handling and queuing is vital. But for non-sensitive data, you don't want to put too much data onto any blockchain. Use alternative protocols, use the right protocol for the right system. And that, in summary, is what we're dealing with today. So all that remains is for me to thank you very much and hope you have a good day.